Welcome to 5.2 Natural Log Integration, Day 2 or Part 2. Today's focus is going to be on the 6 basic trig functions and the integrals of those. Okay, so ones that we know and have known are the first two. The integral of sine is negative cosine plus c. The integral of cosine is sine plus c. But the others we need to essentially memorize. Okay, so make sure you familiarize yourself with these other integrals of the trig functions. Okay, so take a look at them, memorize them, know them, whatever you've got to do. So what we're going to do is we're just going to look at two examples of proving that when you take the integral of the tangent, we end up with negative ln of cosine plus c. And then when we take the integral of secant, we'll end up with the natural log of the absolute value of secant plus tangent plus c. So we're going to go through these two proofs right now. Okay, so our first goal is to prove that the integral of the tangent of x actually is negative ln of the absolute value of cosine of x plus c. So the first thing I want us to do is let's use one of our trig identities to rewrite the tangent. So we all know that tangent is like saying sine over cosine. So now what we can do is we can use a u substitution. Okay, so if we let u be the denominator, right, which is cosine of x, then du is negative sine x dx. So as we go through and we make those substitutions, don't forget to pull this negative on out front, and we really just have the integral of 1 over u du. And what we learned the other day is that the integral of 1 over u is simply the natural log of the absolute value of u. So as we go through and we make our substitution back, don't forget to bring the negative on down for the ride, substitute back in, we get our final answer that is the opposite or negative ln of the absolute value of cosine of x plus c is the integral of the tangent. So there we have it. The next proof is proving that the integral of the secant of x dx is equal to the natural log of the absolute value of secant plus tangent plus c. So this one's a little less straightforward as number one. What we're going to do is we are going to multiply the numerator and the denominator by secant plus tangent. So I'm not changing the value in any way whatsoever. We're simply just helping ourselves out a little bit. Okay? So if I distribute the secant to that numerator, we are left with this portion right here. Okay, now we are going to need a u substitution at this point. So just kind of thinking about what it should be. All right, what do you think we should let u be? Hopefully you say, oh, well, let's let u be the secant plus tangent. And if we do let that be the case, it works out very nicely. What du is secant tangent plus secant squared dx, and that just so happens to be the numerator, right? Plus that or times that dx portion. So it works out very nicely for us. So then as we create our u, or our u substitution, we continue on with the next step. We're really taking the integral of 1 over u du. Well, we know the integral of 1 over u is simply the natural log of the absolute value of u plus c, and now all we have to do is substitute our u back in, and we just proved that the integral of the secant of x dx is really equal to the natural log of the absolute value of secant plus tangent plus c. Okay, I want you to try this example on your own. I want you to integrate the cotangent of 4 theta d theta. So hopefully you recognize, because there is a composition of functions here, we need that u substitution. All right, so go ahead and figure out what your u is going to be, and then you can use the table up above to figure out how to integrate. Give it a shot, come back and check when you're done. All right, hopefully you let u be 4 theta, so then du is 4 d theta, or simply d theta is equal to 1/4 du. So as we're making that substitution, we bring the 1/4 out front, and we're left with the integral of the cotangent of u du. And using that chart from up above, we know that the integral of cotangent of u is natural log of the absolute value of sine of u plus c. All right, and now the last thing we have to do is just substitute back in, and we get our final 1/4 times the natural log of the absolute value of sine of 4 theta plus c. This last example is simply a review problem. I want you to solve the differential equation dy dx equals 3/2 minus x using the point 1, 0. So that means in the end, I want you to find what c is equal to state the final answer. Okay? Now remember, here's your hint. If I'm solving this differential, what it's really saying is y is equal to the integral of 3/2 minus x dx. You will have to use a u substitution, so go through, work it all out, and then see how you did. Step 1, I let u be 2 minus x. So then du is negative dx. Okay? So my first step here is at the same time I bring that negative out front, and we can bring that coefficient or that numerator 3, that constant, out front as well. So we're left with the integral of 1/u du. So integrating 1/u, we get ln of the absolute value of u plus c. That negative 3 is in front, so we bring that down for the ride, and we substitute back in. Okay, but if we're asked to solve using the point 1, 0, we need to go through and solve for that c value. So go ahead, finish the rest up. Using that point 1, 0, and plugging in 0 for y and 1 for x, we go through, and don't forget that the natural log of 1 is really 0, so we end up getting c to be 0, so the ultimate solution through that point 1, 0 is y is equal to negative 3 natural log of the absolute value of 2 minus x. If you have any questions on this video, let me know.